Hello friends, in this video we will be discussing the graphs and how to represent them in a programming language, and then in the subsequent videos we will be discussing the graph traversal. This topic is in the data structure subject and algorithm design subject. So let us begin. So graphs in a programming language. First of all, we need to understand what is a graph. A graph is pictorial representation of relation between nodes. So suppose we have a map of India, then the pictorial representation of all the roads connecting the major cities of the country, that is one example of a graph. Then similarly the airlines that connect the different parts of the country, and how the flights are scheduled, those are different representations of the graph. So basically we have nodes in graph which are related to each other in some manner by some relationship which defines the essence of the graph. For example, here I have a graph with 5 nodes and they are related to each other in some manner. So if two nodes are related to each other, they have an edge between them, and if there is no edge between two nodes, that means they are not related. So this is one example of a graph in which we have nodes A, B, C, D and E. The graph should not be confused with the mathematical graph in which we have a x-axis and a y-axis, and the line series or the pie charts or the area under the curves are calculated. This is not the graph that we are talking about. We are talking about this type of graphs where we have nodes that have a peer-to-peer relation and we have edges that connect the nodes. So here we have the nodes A, B, the set of vertices or the nodes which consists of A, B, C, D and E. And then we have the edges, the set of edges, and that consists of all the edges, like there is an edge between A, B, then there is an edge between B, C, then there is an edge between C, D, there is an edge between D, E, then there is an edge from A to C, then A to D, A to E. Similarly from B to D, then from C to A we have one. So AC and CA, that determines the direction. Suppose we have just this line and no arrow marks are there, that means this is bidirection. A to C and C to A both are possible. But if we put a direction in this edge, then that means that the arrow is only from A to C and we cannot make a reverse strip from C to A because the direction is like this. So there are directional graphs and unidirectional graphs. So there are directional and unidirectional graphs. Directed and undirected graphs are there. So directed graphs are those in which the edges have arrows, and undirected graphs are those in which the edges do not have a arrow. So the set of edges over here, it will contain all the edges that are present in this graph, and this is an undirected graph. Therefore A to B and B to A need not be mentioned separately to represent the edge. If it was directional, then A to B and B to A, if both paths are possible, then they must be enumerated separately. Then we have weighted graphs. Weighted graphs are those in which on the edges we put some weight. Suppose from A to B the weight is 2, that means the cost of moving from A to B is 2. And B to A is also 2. And then we have 3 over here, so cost of moving from B to C is 3. And if it is a directional edge and we put a cost over here 3, that means from A to C the cost is 3. And if we put another arrow here and we say 2 here, that means from C to A the cost is 2 and from A to C the cost is 3. So this way we can have weighted edges also. Now the question arises how to represent this data structure inside the computer's memory. There are two representations. One is the linked representation and the other is the array representation. So in array representation, what we will do, array representation of graph, what we are going to do is, whatever is the graph, suppose this is I'm taking a simple example. I'm taking 4 nodes and they are connected like this. And this is A, B, C and D. So what I will do is I will reserve a 2-dimensional array. There are 4 nodes, so I am going to reserve 4 by 4 array. So 0, 1, 2 and 3. Similarly I have 0, 1, 2 and 3. These are the columns, these are the rows. And what I will do is with each number I will associate a vertex. So this is A, this is B, this is C, this is D. Similarly here, this is A, this is B, C and D. Now, whether there is an edge between A and A will be represented by this cell. So A doesn't have a self loop, so we will make an entry of 0. Now, whether there is an edge between A and B, yes. So yes is represented by 1 and no is represented by 0. Then between A and C, yes. A and D, yes. Then from B to A, do we have an edge? Yes, since this is undirected graph, so there is an edge from A to B and the same is from B to A. Then B to B we don't have, B to C we have an edge, B to D we don't have an edge. Then from C to A we have an edge, C to B also we have, C to C we don't have and C to D also we don't have. Then from D to A we have an edge, D to B we don't have, D to C we don't have and D to D we don't have. So this is the 2-dimensional representation in the form of an array. And in the linked representation, we will maintain a linked list. So a linked list of nodes first of all. So we will have a linked list of nodes. There are 4 nodes. So we are going to have 4 elements in the linked list. And we put entries over here. This is A, this is B, this is C, this is D. And then we have other pointer which points towards the chain of edges. So A is linked with B. It also has a A also has an edge with C. And it also has an edge with D. So all the nodes with which A has an edge, their entry will be made here. Then B has an edge with A. Then B has an edge with C. That's it. Similarly, C has an edge with A and B. So two levels of linked list are there. One is between the nodes and one is between the edges of that node. So D has an edge with A. B has an edge with A only. So null. So this way we can represent the graph in the form of an array using a two-dimensional array or in the form of linked list. If we have to add a new node to this representation, array representation, then it is very costly because you have to reallocate space to the whole array. But if we have to add a new node to the linked representation, it is comparatively easy. But locating a edge in this particular arrangement of an array is easy, but in the linked representation it is a costly operation because linear search needs to be performed. So that way both the methods, they have their own pros and cons. So in the next video we will be discussing the breadth first search traversal. Thank you.